Okay, I'm going to share the solutions here. Can you all see that? You can resize it by, on the left-hand side, there's a little, I don't know, magnifying glass icon, so you can zoom in on it, make it a little bigger. Everybody see that? Everybody okay with that or not?
Yes.
Okay, cool. I'm actually going to skip to the very last problem, okay? I'm going to the very last one. This is the one that I think is, the other ones people seem to do pretty well on, especially if they practice, look at the old exams. But this is the one that gets a little sticky. Your chapter 3 discussion asks you to take, for those of you that haven't done discussion for chapter 3 yet, it asks you to find the mean and standard deviation of your sample of arrests that you did in the chapter 1 and 2 discussion. Well, you take that mean and that standard deviation, and then you compare either your weight to that, or you pick your favorite actor or actress who plays a villain. So you can just pick anybody. Honestly, it doesn't matter. And then find the z-score. So that's the formula right here, like z equals, and then this would be x. Here, I'll do the formula underneath it. Z equals x, and then in that case, that would be x bar. X bar means sample mean, and then S. Now really, if you're talking about populations here, so if I know the population of basketball players is that height with that standard deviation, then I can compare it. That would be sigma for the standard deviation and mu for the mean. So if you see a Greek letter like this, mu is mean, and it's not just the mean, it's the population mean. Cool? So if it's Greek, it has to do with the population, and then sigma is the population standard deviation. Standard deviation. And if it's just English, it's talking about the sample. So you're just getting used to this. You're getting used to this idea of the normal distribution. Chapter 6 is where you really hit it even harder. But what we're given here that this average height of this team is 6'9", or yep, the team center, that piece of data is 6.9 feet, so it's not 6'9", 6.9 feet, and the average is 6. So you take 0.9 divided by 0.4 and you get 2.25. So that one person is 2.25 standard deviations above normal. That's the z-score. So z-score is just describing how many standard deviations above or below normal. It's like a way of measuring how far away from the center something is. And then if you look up 2.25 on your Z table or your on StatCrunch under your normal calculator, and there's a video right before the discussion on kind of showing the two different ways, and I don't really care which way you do it. The only reason I show you the tables is to maybe it helps you kind of get a perception of it better, but you can just use StatCrunch normal calculator. And if you put 2.25 in, you're going to get it's in the 0.98878. It's the 98th, almost 99th percentile. So if I draw a picture of that, here's the normal distribution. Here's right in the middle. If I'm up here at 2.25, this is like over here is like 98%. So then the percent above would be like 1.22, right? So 1.22% is taller than that. And then asks, is that unusual? The answer is yes. Because it's usually a rule of thumb if it's less than 5% or more than 2 standard deviations. We'll talk more about that as the course goes on. So this thing right here, how many of you either say yes or no in the chat have done a z-score problem yet on your homework or something, have seen this on your discussion? Anybody just give me a thumbs up or a yes or a no in the chat if you've done a z-score problem like this. Okay, yeah, they're it's in the last section of chapter 3. So if you've done the chapter 3 homework, yeah, and you can use the z-table for sure. And I would encourage you to also use StatCrunch and use the normal calculator. And that video is in there as well. In fact, I can put that link, I'll just put the link to that video right in the chat, okay? Just so you don't miss it. Yeah, here we go. It's right before the discussion here. My colleague David Gish made it. Copy this URL. So I'll put this right in the chat. So this shows you how to use StatCrunch as well and how to find that. So if you're trying to find the percentile rank, that's the area to the left. If you want to say what's the percent of that or more, that would be area to the right, which would just be 1 minus that because the whole thing is 100%. So this, using the z-score, finding z-score and then just finding that percentile rank is a very important concept that we'll use throughout the course actually. And then 12 here is another example of doing this. So this is, again, they give you the average is 79. What percent is between 49 and 89? So you can find the z-score of each one. That's 89 is 1 standard deviation above because it's 10 above. Standard deviation is 10, so it's 1 standard deviation above. But 49 is 3 standard deviations below, which is a -3. Now, if you look up those on your z-table, you're going to say anything below 89, I'll just shade this, anything below 89 is 84%. Anything below 49 is like 0.0013%, almost none. So the difference between those two is about 84%. That would be the area in between. So you take the whole thing minus this little tail, and that will give you what's left over, which is the in between. And you could also use the empirical rule here. The empirical rule is like it just generalizes. It's not as specific as the z-table, but it's the same idea. Where if you're 1 standard deviation above and below, that's like 68%. 2 both ways is 95. 3 both ways is 99.7. And you could use that type of thinking. But honestly, this is the way we'll do it the rest of the course. This is more straightforward, and you can find the area between the percentage between there. And then the last one, 13. Any questions on 11 and 12 before I go on? Yes, the percentile rank. So here, you want me to do it the Z? I'll do it the Z table first. So if I'm looking at the Z table here, I have a positive z-score of 2.25, so I need to go to the positive side here. So 2.2, I'll use my pointer here, 2.2, and then I gotta go over to 5 here. There it is. There's where that 0.9878 comes from. So that means it's like almost the 99th percentile. Hold on. Hey, everybody, the link did not update in the announcement, so I'm resending it again. Sorry. All right, sorry about that. For some reason, the link did not update in the announcement for the 8-week section, so I had to redo it. So they'll be coming in here. All right, so let me share that again. All right, so again, that 2.25 right there, 2.2, and then get over the hundredths digits right there. So that's how you find that percentile rank. Does that answer your question, Courtney? And the Z table always gives you area to the left. Okay, cool. And then if you want an area to the right, you just take 1 minus that number, and that tells you how much is to the right. And then the between is you take both the numbers you would get off this table and find the difference between those two, and that gives you the area between. And yeah, so let me go back. Let me pull up your exam again, the old exam. All right, so there. So that's kind of how to take the Z-score, find the percentile rank. Again, this is the kind of the same thinking. Find the Z-score, find the 2 percentile ranks, find the difference. And this last one, 13, is a little more advanced. I would say it's the stretch question for the first exam is kind of like that. In fact, you can see I made this extra credit in the past before too, because it is a stretch. So what they're saying now is, okay, what score do you need to get to kind of be at that level or at that Z-score or at that percentile rank? So this is a really good one to kind of show everything you might need to know about this. So it asks like, which is better, a score of 92 on a test with an average of 71, a standard deviation of 15, or a score of 688 on a test with a mean of 493 and a standard deviation of 150. You're like, oh, who knows, right? This is the cool thing about Z-scores. It lets us normalize these, or it makes us put them on a similar scale. So we use the same Z-score formula where that's X bar mu, and standard deviation. So a score of 92 is the score, average is 71, standard deviation is 15. So that's 1.4 standard deviations above normal. And the other test, 688 is the score, average is 493, 150 is like, no, the 15 and 150, that's like the ruler, that's the average amount of spread. So, so the question is, which one of these is further away from the middle or higher? And it looks like this one right here, the 92 is 1.4 standard deviations above normal, where the 688 is 1.3. So we'd say the 92 is better. And then the stretch question here, and I don't think this is this is kind of, it's like, for extra credit, find the score on the first exam is equivalent to the score on the second exam. So I kind of allowed it both ways, but really what this is asking is, what score would I get on this one, this average 71, standard deviation 15, to be the equivalent on this one, or vice versa, right? I allowed it either way. So we could go, okay, I need to be 1.3 standard deviations above normal. I don't know what score that is, but I knew the average, the mean, and the standard deviation. So all I have to do is a little bit of algebra. This is like the most algebra you have to do in this class, is just multiply by 15 on both sides and then add the 71. So a score of 90.5 is the same as a 688 on this exam, because they're the same. They're both 1.3 standard deviations above the normal. And that was an extra credit question, but that type of thinking. So I think for fun, what we should do is, hey, how about we find the percentile rank if it's normally distributed? Let's find the percent for 1.3. So let's do that. 0.3. So let me do that. So if I look up 1.3 in the Z table, 1.3 right there, 1.30. So that's like the 90th percentile, 90.32%. 90th percentile would be, and 1.4 is 91st, 91.2%, or 91.92%. So above the normal, or that's the area to the left. It's kind of the percentile ranks. So those types of problems are, if you can get those types of problems figured out and practice those, so that's why I'd encourage you to do, I would encourage you to just go through all the old exams, go through all the solutions videos, go through all the tests, or just try to, what I would say is try to just do one and then go back and look at the answers, and do I would do all the old ones, just to get more practice problems like this. And there are some in section 3.4 homework as well that you could hit similar example and keep practicing them as well. All right, so Michaela, is that helpful for that exam, this exam that's coming up over chapters 1 through 3?
Yeah, it is. It helped a lot. Thank you.
Okay, is there, for the review you've done, are there other ones that seem weird, or are they pretty straightforward?
All the others seem fine.
Yeah, I think in general, students, they get like, what's a sample, what's a population?
Yeah.
One thing I think is a really cool, or not cool, critical thing, and I'll ask the whole group, everybody chat in, what do you think is the best method for sampling? What's the most preferred sampling method?
Random?
Yeah, random would be best, wouldn't it? Does anybody know why we should use random?
It removes even subconscious bias from the selection of the sample.
Very good. Yes, that is the #1 reason to use randomness, is to reduce the bias of the sample. We're trying to find representative samples as best we can, and the best way to do this is just to do it randomly. Think of a big pot of stew, right? Well, I'm going to take a bite out of the stew. Now, if I just threw all the junk in the stew and started cooking it, there's going to be some some spots have like more potatoes or vegetables or meat, all right? But if I stir the pot up, you can kind of say, you know what? If I take a bite of that, it's probably going to taste like the rest of the pot. Think of randomness as like stirring the pot up, if that helps analogize what random, makes it so your sample has a better chance of being representative of the population you're pulling from, and reduces the bias. There's always some bias, but trying to control for bias, randomness is a really good way to do that. So thank you. All right. Okay, is there, if I go to Alyssa now?
Yes, that's fine. Thank you.
Okay, cool. Yeah. All right. Very good. That was huge, I think, for everybody. All right, Alyssa, do you have anything like specifically you'd like to talk about or thing you're working on? I don't know if you're in the 8-week or 16-week. I guess I can turn my camera back on, sorry. Alyssa, I don't know if you can hear me or not, or if maybe you don't have a mic there, I don't know. Or you can just chat into if you're good or if you have anything specific. I'm just going on the list, give everybody a chance to chime in if they have a specific question. Okay, I'll go on to Courtney. Courtney, how about you? Anything else that you'd like specific that you're working on, or question from homework, or? Oh, okay. Thank you, Alyssa. Courtney, how about you? All right. Is it Jomari?
Joe Marie.
Joe Marie. All right, Joe Marie. What do you have anything you'd like to chat about?
I'm okay. First of all, I'm in the 8-week class.
Okay, cool.
Because you said like you're gonna be talking about the final project.
Yes. Because I had a few people contact me with some ideas already, or they sometimes in the introductory discussion board, people will say like, hey, I'm really into this thing, and it kind of leads to a discussion about some ideas that might be used. The final project obviously isn't really something we work on until the last few weeks of the course, but it's never too early to start thinking about it. So, for instance, what's your major?
I'm trying to get into nursing, so I'm
Okay.
doing nursing right now.
Okay, cool. So a lot of nursing students take this class. So a lot of them like to pick something maybe from the nursing or medical field, some type of question that they've had. Sometimes it might be like they're dietitians, or they're in maternity wards, or they're in cancer things. So there's a ton of good questions that can be asked about the medical field. Now, obviously, this is an introductory course. You're not going to be doing your own research. What you're going to be doing is asking a question, seeking out data sets that can help answer that question, and then analyzing them, and then kind of reporting back about those. And the reason, like in week 6, I think it is, you're like, there's a discussion board where you just kind of post your idea, right? And then everybody can kind of chime in with questions that you might want to ask, and where you get your sample, and it gets you started on the project. So if there's something specific right now, like obviously these last 2 semesters, I've had a lot of projects about COVID. So people are analyzing a lot of the data. They might be looking at, maybe Polk County versus another county, or Iowa versus the United States, or certain groups of populations compared to the general population, or infection rates versus hospitalization rates, or
I was thinking about that.
yeah, there's a whole smear of questions that can be asked in regards to that. And so my job will be, especially as that gets closer, is just kind of help you refine your thinking, narrow your question that you want to answer. And a lot of it's going to come down to what data can you get access to, right? So, and it doesn't have to be in your major even. It could be something you're just like interested in. Like I've had people like in fashion design, right? So they like certain TV shows or certain genres of sports or books or something.
Music.
You can ask questions about that. Yeah.
That's good. All right. Thank you so much.
Yeah, no problem. So if you've got, like I've already fielded a few emails from folks saying, hey, I'm thinking about this for my final project. What do you think? And that's great. And I can go, oh, that's pretty cool. Here's a link that you could go start looking at to find some data sets, and start trying to find out what question you can answer. We haven't learned enough for you to do any of the analysis yet, but you've learned enough to start thinking about samples. You can start thinking about what we haven't started talking about hypothesis testing yet, but that's for your class. It's coming really soon, which will come after this exam over chapters 4 through 6. So what's that, week and a half?
Mm-hmm.
So that's when you'll really start cranking on actual analysis.
Okay.
So for the 8-week students, it's appropriate to just start thinking about it. And what's the cool thing is if let's say you post something like, hey, here's the question I have, and then you're like, man, I can't find anything on this, or this isn't going to work. that's totally cool. You can change course. And what I'm interested in is by the end of the course, can you do something and show me? It's a chance for you to show me what you know. So
Sounds good. Thank you.
you bet. You bet. Great. Thanks. Yeah, thank you for asking that. All right. Josh, how about you? I don't know if you can hear me or not, or maybe you don't have a mic or you can chat in, possibly. Oh, okay. So I got a chat from Courtney. Okay. All right. How about Kira? Oh, okay. Thank you, Josh.
No questions, just wanted to go over the old exam, so that was helpful.
Okay. Awesome. So, and I would, and obviously, and you've seen in there that I've made a short video kind of going over the answers for every one of those tests too. So, you know, that, but I would even like just take one of the old ones and just try to write it out, right? And just see how you do, and then kind of helps, you know, point out if you've got some things to work on before you click that start the test button. For some reason, I have some people that are like really, really anxious to take the exam. So they'll like it essentially the beginning of the week is tomorrow, right? And you got until next Tuesday to complete that exam. Some people are like, oh, I got to get it done by Thursday or Friday. And I'm like, well, you don't have to. I mean, and then they're like, I've had a few people do poorly. And I'm like, did you go through any of the review stuff? Did you go back over my math lab homework? Did you go over the ones you kind of struggled with? Did you, go over the old exams? And they're like, I didn't really do that. I'm like, well, you should have. That would be very helpful and important to review. So for the 16-week course, you get a whole week to work on that, which is probably more than you need. But it gives you ample time to review. And so just make sure you set aside a couple hours. And then you'll use the same app you use for that uploading a document, that CamScanner app, to put the document on Blackboard. It's the same process as you did for that. So you've practiced that once. But make sure you leave yourself, whatever that takes, 5-10 minutes, whatever, to do that. The test usually only takes about an hour, but I give you a 2-hour window. So that gives you plenty of time to complete it and upload it. But if you have any problems during your exam, that's really weird, feel free to just give me a call on my cell. And I think everybody's got my cell phone number. Is that correct? I'll put it in the chat just in case. I think it's in the service too. I thought I was going to use a sweet little Jabber app. It's going to automatically forward my office calls to my cell. DMAC stopped forwarding calls automatically. I've been doing that for like 12 years. And they changed phone systems, so they're like, oh, use this app, and it's worked horribly. It doesn't really work, so I've relented. So I may have to go to Google Voice or something. But anyways, for this semester, there's my cell phone. Just don't kill me. Just don't call me at a horrible hour. But I'm usually pretty responsive. All right. How about Crystal? How about you? Is anything?
I'm in the 8-week course, and really, I guess I don't really have much concern. Just wanted to kind of go over the test and maybe learn from my mistakes to not make on the next test. I did have I was one of the students that had a little trouble uploading on time. Even though I was finished, I was just kind of rushing to like upload because my time was running out. But I've never had that issue before with CamScanner. Normally it just goes straight to my downloads. For some reason it got lost in my downloads.
Nope, it always happens when you have to take your stupid test, doesn't it?
Yes.
So
right.
frustrating. No, I totally understand. And so well, do you want to offer advice to anybody else that hasn't taken the first exam yet from the other section? Any advice for them you'd like to give them?
When you save it, I would name it something different. Don't name it like the CamScanner, because it could get lost with your other CamScanner stuff. Like if you have other classes, right, you have to upload CamScanner with, like it can be hard to find.
Okay.
If it's like the same name, I would like name it Stats Test 1 or something.
When I do it, when I hit the share button, right, and I usually share it and make it a PDF, but I usually send it to myself through my email on my phone.
Yeah.
And so then I'm like, then it's easier for me to find it, right? Because it's an attachment on an email and I can easily get to it. But I like your idea of, especially if you're doing it, kind of that way. That's great.
Yeah. But I
And
guess
I will be releasing the solutions. I have one student who hasn't taken it yet.
okay.
It's, well, essentially they're going to get a 0, I think. But I'm still holding off hope. Anyway, I'm definitely being too lenient. How's that sound? So anyway, but when that happens, I'll release those solutions and then go over, and then hopefully it'll be, go over the answers and stuff. And then if there's specific things like how did I get this score kind of stuff after you watch that, then just shoot me an email and I can usually explain it.
Right. I'm not mad at my score either. I think it was pretty good for like the first exam. I am kind of struggling though for some reason on chapter 4, like the very last part, the chapter 4.4. For some reason, I'll do it on the calculator and it seems right, but then when I punch it into my stat lab, it says it's wrong.
Oh yeah, gosh. Sometimes it's a rounding error.
Yeah.
Of course.
Yeah.
Which section are you on?
Well, I finished 4.4 to the
Oh,
best I
okay.
could. It's just not that great.
What do you want to, because you can always redo them to get 100%. Did you know that?
Right. Yes.
Yeah, okay. You can get similar exercise. Is there one you would like to go over maybe, or just shoot me and ask me, my instructor, and send it to me and we could go over it right now?
Yeah.
Or I could come back to it or whatever you'd like.
Hang on. That's not the right one. Yeah, like I only got 6 out of 12 points on 4.4. Most of them, so I got like 6 of them wrong.
So you should redo those to get 100%. Okay.
Yeah.
Okay. Do you want to? Yeah, shoot me one of those.
Ask my instructor. Okay, I just sent you one. I don't know if I did it right, but
All right. Let me check here. Okay. Let me see. All right. Yep, I got it. All right. I might share this to the screen here. Give me a second. All right. Okay. Yeah, this is a counting one. All right. So it says when testing for a current in a cable with 12 color-coded wires, the author used a meter to test 5 wires at a time. How many different tests are required for every possible pairing of the 5 wires? The number of tests required is, and then they have that one. Okay. So if you, so for instance, in this one, does order matter? Like if they're testing 5 at a time, does it matter what order you're testing them? I mean, does like blue, white different than white, blue? What do you think? I mean, if I test the blue one and test the white one, it's the same as if I test the white one and then the blue one, right? That's just, I'm testing both of those, right? Or those sets of 5 is what that is. So if order doesn't matter, it's what we call combinations. If order does matter, then we're going to use permutations, okay? So in this case, N is the number of cables, so that's 12, right? And how many can we test at a time? That's 5. So it's like how many groups of 5 do I need to check to essentially get all of them, right?
mm-hmm.
So if you'd go 12C5, do you know how to do that in your calculator?
Yeah.
I think you can actually, if you actually have you ever used the website Wolfram Alpha too?
I haven't.
I'll put
I
that.
just found, I dug out my TI-84 for this section specifically.
Okay.
I couldn't find it, but I finally did find it.
I put it in the chat too there. So if you go to that site, what's cool is you get to 12C5 and it'll actually know that that is combinations and it'll give you the number, which is 792, right?
Mhm.
And I think that's the right answer.
Yeah, it is.
Okay. So that's a
My
little,
answer that I got for some reason was, I think, 490 something.
yeah.
So I was off by a couple hundred.
Yep. But that's a counting one where, so pretty much 4-4 is just going to be testing your ability to use permutations and combinations. It gets a little tricky sometimes. So like, for instance, if two of the wires were the same color, then it's like, or if you're talking about how many different ways could I arrange the words in Mississippi, right? And there's M-I-S-I, right? And there's repeated letters. Then you have to divide by the number of repeats. And there's some examples in the show me an example and in the text about that. That's the only tricky part there. I don't ask you any of those tricky ones. They're not that tricky on your test. You'll see from the sample exams they're not that bad.
Okay.
So is that helpful for now?
Yes, yes, it is.
Awesome. Awesome. All right. Well, and I'll keep going around and I'll come back around. So Madison, how about you?
I don't have any questions.
Okay. Are you in the 8-week or 16-week?
8.
8-week. All right. So we got a lot of things due tonight. How you doing on that?
I'm done.
Oh, well, good work. Good job. Aren't you supposed to wait till 10 o'clock to start working on that stuff?
I've been busy.
No, I'm just talking about every other online student.
Oh, well.
That's awesome. No, good job. Good job. Way to get on it. Stay ahead. That's I'm also taking a class that's kind of online but we have a live session every Thursday night. So I get it. So like this week I'm actually a little ahead. I feel like I've already gotten everything done for Thursday night, which feels really good. Yeah. But the problem is I'm taking a class in Greek, and so you're never done. So anyway, there's always vocab and flashcards to go over.
That sucks.
Yeah, it's especially when you're 48 years old like me. Keep learning when you're young. That's all I'm gonna say. All right. How about Maddie? How about you? Oh, I think I see a microphone. Oh, maybe not anymore. Or just you want to chat in there if you got anything? And I think well, I'll come back to you. How about, it's Thatcher, right? Is that correct?
Right. I'll go by Lane now, so that's cool.
Okay. Lane, all right. Lane, you're working on the project around marbles, right?
Yeah, there's a video game called Marbles on Stream. That's a Twitch game, a Twitch TV game. So as you saw in my email, I'm basically going to take the inspiration of the statisticians look at the Jellies Marbles YouTube stuff and see if the creator of the Marbles on Stream program the marbles actually complete the track in a random fashion. So my thinking is I will get 28 marbles, run them about 40 times through a track. That way I'm going to keep track of their placement of order and their actual times in completing the track.
Nice.
So I can look at, if they are random, they should all have about the same probability of getting an equal distribution amongst placements.
Right. Yeah. No, very cool.
Should create a bell curve for the average speed of the race.
Cool.
And so then I'm going to look at the marble, see if there's any marble that is significantly offset. I'm going to name the marbles actually after famous literary dwarfs. So I've got Sneezy, Dopey, Doc. I've got Willow, Tyrion Lannister. that kind of stuff.
Cool.
And just have some fun with it. So
Yeah, no, that's fun. So that's going above and beyond actually gathering your own data, but it sounds like, well, you have a passion for it and it's
Yeah.
relevant to you, so that's awesome.
yeah,
And boy, the last few chapters, we do things over things like, it's called goodness of fit.
Mhm.
So you have an expected distribution of an expected even distribution, and then you're going to have an observed, and then you can do a chi-squared analysis to see if they're significantly different. And also then, like you say, you could actually find mean and standard deviation of the races, find significance of each one compared to your group. So you can do a lot of cool analysis. Like I said, you're going over and above, but it sounds like it's going to be awesome.
yeah, I'm gonna have fun with it. And also, I haven't received word back from the developer. It's a small 3-person company, but there is a online community of players. And so I thought once I got this all knocked out, I could share it with that online community
Nice.
to show them that yes, your ball isn't biased to win or lose based. Everyone has the same chance. So
Very cool. Yeah, this is what they do with dice at Vegas, right? See if it is statistically significantly messed up, or if there's some irregularity or whatever. We had a math conference in Vegas here for our national math group, and they gave us all an extremely weighted die. So that was fun. So I kind of I geeked out and said, oh, I wonder what the expected value is of this die, and rolled it a whole bunch of times. And it's like, it was obviously super weighted, but it's still kind of fun to go get how often it would come up with not a 6 kind of thing. So anyway, no, that's cool. I'll be excited to see that. And if you want, you can share that channel on the chat right now. If you wanted to, people want to check out that Twitch channel, if they're interested. I know during COVID, marble racing got stupid popular because it was like the only thing people could gamble on still. They couldn't even bet on car racing anymore, so they actually had marble racing, and people would bet on marbles. It just shows you people do anything to gamble. So that's awesome. So that's so cool. That's a great example. It can be something, whatever you're into is just great. So all right, how about Trisha? And it looks like I might have 2 Trishas, or maybe it's the same Trisha. I don't know.
I'm in as Trisha H, and I just came to kind of go over question 10 on the exam.
Okay, and is that the 2019, 2020?
2020.
The one we just took?
Yep.
All right, I'd love to go over with you, but there's some people in this room that haven't taken that test yet, so I'm not gonna. So how about shoot me an email and I'll help. How's that?
Okay, sounds good.
Yeah, and I'll be releasing the solutions. Like I said, I don't know if you're in here before, but I have one student who's delinquent, and
I came in late to the session.
Oh no, you're not delinquent. I'm talking about this other student that hasn't taken the test yet, and I should have gave it. I've told them they got a 0, and I'm still waiting for communication back, which is not a good sign. So anyway, I'll release the solutions when I'm fully convinced there's no hope. But anyway, then that might help too. So, and then you can look at the video and I'll explain it. And then we can follow up again. How's that sound?
Perfect, thanks.
Yeah, sorry about that. All right. All right, so I've gotten through the whole list, I think. So now, just in general, other follow-up questions that you might have based on what you've heard. Those of you that weren't here early, we went over finding z-scores and things like that, and I did record the session, so I'm hoping to post that as well. But I could go over that again if anybody wants to.
I showed up late to the session, so you said you went over z-scores. Is that what you just said?
Yes. Yep.
Could we go over that a little bit?
Sure, yeah.
Okay.
So what I'll do is I'll pull up the test from 2019. That's on Blackboard for you, okay? And I just went over the last problem. And have you had a chance to look? You probably haven't had a chance to look at this yet, but these types of problems are are really good ones to practice, and there should be ones like this on every practice exam out there. So pretty much a z-score is just asking how many standard deviations is a piece of data away from the mean. So in this case, this basketball player is 6.9 feet, but the average is 6. So we know it's 0.9 away. And the formula is where this is just x minus x bar. We can also use mu. And if we use Greek symbols, it's talking about the population. If we're using English, we're talking about the sample. Whoa, what happened there? And then the denominator is s, or we can use the Greek sigma, and that's the standard deviation. So we know that it's 0.9 away. The standard deviation is 0.4. That's like the average spread of the data, which means that basketball player is 2.25 standard deviations above normal. And we kind of know when you're more than 2 standard deviations, that's what, we start saying that's kind of weird or abnormal or unusual, right? So this player is unusually tall. But the question is, like, what's the percentile rank? If basketball players are normally distributed with an average of 6 and a standard deviation of 0.4, what's the percentile rank? And this is where this 98.78, and that's the Z table, or you can use the normal calculator. And there is a video, and I put it in the chat, I don't know, up here. You see that YouTube link right there? That's in Blackboard right before your Chapter 3 discussion. That's a good one to watch. That kind of shows both methods that I'm showing right now too. I'm not showing you the normal calculator on StatCrunch, but that shows that as well. But I'll just go ahead and share the Z table. So if we look up 2.25, then I'll go to the positive Z-scores. 2.25 is right here. I'll use a pointer. 2.25. So there it is. That's where that 0.9878. So that's the percent that are below 6.9 feet tall. If I want to say what percent are above, you just take 1 minus that, because the area under the curve is 1. So it'd be about 1.22%. Is that helpful?
Yes, that helps. Thank you.
Yeah, and then I'll go through this next part here too. Hold on real quick. And then the next question on this is asking what percent are between, like the average test score is 79, what percent is between 49 and 89? Well, you find those two Z-scores. 89 is 1 standard deviation above normal, because the standard deviation is 10. It's 10 above. It's 1 above. 49 is 3 below, so that's a negative, so it tells me it's 3 below. So if you look up 1 on your Z table, it's 0.8413. If you look up -3 in the Z table, it's 0.0013. So what percentage is in between? Just find the difference between those two. So it's 84% is between those two. And then the 13 is a little more tricky, but pretty much asking which is better, a score of 92 on this exam or a score of 688 on this exam. Well, the question is, well, it depends. What's the average and what's the average spread? So we find the Z-scores for each. 92 minus 71 divided by 15 is the average spread. So that's 1.4 standard deviations above normal. This one is 1.3 standard deviations above normal. So the 92 on the first exam is slightly better than the 688 on this other exam. And then this last part was for extra credit. It'd be like, so what's the equivalent, what would I have to score on this first exam to be exactly the same as on the second exam? Well, I know it has to have a Z-score of 1.3. I don't know the score, but I do know the mean and standard deviation. So just doing a little algebra, cross multiply by 15, and then add 71. So a 90.5 on this first exam is the equivalent of a 688 on the second exam. So those are the type of problems that I overemphasize on my first exam, because it's the most important thing that you've learned so far. So, and we keep using this type of thinking throughout the course. There, I went through all that again. Is that okay? Sorry.
Yes, thank you.
I went through a little quicker, but hopefully hopefully the recording is happening, and hopefully you can send it so you can watch that again. But practice all of those for sure on the old exams, okay? And then if you weren't here earlier, one other thing we talked about was what's the best sampling type, and we were saying random is the best. And why is it? Because it reduces bias. It gives you the most representative sample of the population. So it reduces bias. All right. So, and sorry about that screwed up link. That's on me. I'm so sorry. I don't know what happened there. You know, who knows? I probably did it late at night and didn't copy paste the right thing. So hopefully I don't screw it up next. We will be having an office hour next Monday night as well. And I'll send out a reminder right before that as well. So I'll hopefully be correct on that one. So for those of you that are taking the exam, that would be another opportunity that you could get a quick review in before you take it on Tuesday, let's say, or even Monday night late, I suppose. Doing it from 8 o'clock to 9 o'clock p.m. on Monday. All right. I'll open it up again. Thank you for asking that, though. Other questions that you all might have. All right. Yeah, and I see some people are taking off. That's totally cool. Or I'll stick around if somebody wants to ask something specific. Or who was it that asked about question 10 on the current exam? I'm sorry, who was that again? Or did she leave? Because I could, when everybody leaves, we could chat. Was that Trisha? Yeah, Trisha.
Trisha. Yep.
Yeah, so if everybody else takes off, I can stop the recording and then we can just go over that one question if you'd like real quick.
Okay.
Yeah, so maybe just hang out and wait for everybody to bug out and then I'll pull it up and we'll go over it. How's that?
That sounds good.
All right. Well, if you have no further questions, I'm going to go ahead and stop the recording. And